Hi, thank you for watching this video on what's new in VSS. The first thing you should do when you start the AWR design environment to learn what's new in VSS is go to the toolbar and select Help, What's New, and then click here on Visual System Simulator. You'll find a bunch of information on what's new in VSS. In this video, I'm going to touch upon a few subjects of what's new in VSS. Specifically, we'll talk about the new bi-directional capability. We'll talk about the new source port that has been added to VSS. And then we'll talk about improvements and added features to our phased array antenna model. So I have a select few examples to illustrate what's new in VSS. The first one we'll highlight is the new capability in the phased array model. In previous versions of the phased array model, each element pattern had to be isotropic. In the new version of the antenna model, we allow you to import an antenna pattern for each element. The data file is a common format. It's illustrated here. So we import that into the model. And what we're going to look at here is the antenna pattern of one of the elements. And we can make a comparison of a rectangular antenna pattern, a 75 element rectangular pattern. The red trace is when each element is isotropic, and the resulting green trace illustrates the antenna pattern when the antenna elements are not isotropic. Another feature that we can highlight in the system diagram is the new bidirectional capability of VSS. If you look closely at the antenna ports, you'll see over here that we have triangles going from left to right and right to left. Anytime you see this port in our RF models, that indicates bidirectional capability. The orientation of the antenna indicates whether it's in a transmit mode or a receive mode. In this case, we have a source coming into the antenna, and this orientation indicates it's in transmit mode. The received orientation is indicated over here. This will tell VSS that the signal is coming in here, and that's the received, and then going onward to the received RF structure. If you recall, and if we look back at the old method of defining antennas, we had individual antennas for received and transmit. Now, in version 12, we have one antenna, and the orientation of this pattern indicates whether it's in transmit or received mode. I have a project here where we'll specifically talk about bidirectional capability. And we'll also be highlighting a new RF model in VSS. The new RF model that we're highlighting here is the directional switch. Note here the direction of the signal is going from port 1 to port 3. If I switch the on position here to port 2, you'll see that the signal now is going from port 3 to port 2. If we look at the system over here, I'm going to be making a measurement on the transmit link. So when I run the simulation, the first graph we'll look at is transmit power. I start the simulation. We can see here that I have approximately 30 dBm worth of transmit power on the transmit link. Now, if I go back to the switch and indicate an on position of 1, you'll see the flow of the signal goes from port 1 to port 3, and the measurement of interest will here be the receiver noise figure, which in this case is approximately 2 dB. Going back to the system diagram, you'll see here that we handle the flow of data in either direction, and ports or items or RF models that do not support bidirectional capability are indicated by one triangle going in one direction. All, if not most, of our RF models support bidirectional capability as indicated by these triangles here. The last thing we'll talk about is the new source that's been added to VSS. The purpose of having this new source is to give microwave office users an easier transition into VSS. And specifically, if you compare the new ports in VSS to the ports that currently exist in microwave office, you'll see distinct similarity. So in this method, we have our port source. I can indicate whether to use the system frequencies, use dock frequency. I can specify a specific frequency, or I can specify things in terms of period as opposed to frequency. So here we'll say specify a frequency. We'll leave it at a default at 1 gigahertz. The next thing that we have to do here is add a graph for the measurement, previously added a test point. We'll add a graph, and to this graph I'll say add new measurement. We'll select spectrum measurement, power spectrum, indicate test point 1, dBm, click OK, run the simulation, and now we can see the 1000 megahertz signal being generated. If we go back here onto the palette of ports available to you, you have add port. That is similar to the microwave office ports. Generally, when you're working with an RF device under test and it has bidirectional capability, you'd be using this port. This port is exactly the same for what is in microwave office. And if we go back here to ports, you'll see the existing ports that have been in VSS since its inception. If you continue reading the What's New in VSS, you'll find that we added a select few measurements and several RF models.